Okay. So this is the ACSL recursion section of the qualifying questions for the contests, right? Recursion is a very important topic in computer science in general, and with ACSL, they like to focus on how you solve particular problems using a recursive method. So there are several ways that they can do that. They usually present you a problem, and then you solve the problem by putting new values in as you generate them in a recursive way. The best way to explain this from the ACSL point of view is to look at a particular problem that they give you. So I'm going to write one on the board, okay, and here's the problem that they give. Okay, so the functions so this is a typical function equals. Now, usually when you have recursion, there are two or more ways that you can get the next answer. All right, so this gets redefined as a function x minus y, y minus 1 plus 2 if when x is greater than y. And it gets redefined as x plus y when y otherwise. So the reason this is a recursive problem for solution is the fact that sometimes this will be the rewritten equation, and sometimes this will be the rewritten equation, and the way the problem solution progresses, at some point you get to this solution, which then fills back into the previous temporary solutions that you worked with, okay? So, if we take a specific, here's a case problem, This is with x equal to 12 and y equal to 6. So we would start substituting. So we're going to say the function of 12, 6 is equal to, well, we see 12 is greater than 6. So therefore this case applies. What this is going to be then is a rewrite of what this function is. So this function will be x minus y, which is 12 minus 6. So 12 minus 6 is 6. And the second coordinate for the function would be y minus 1, so y is 6, minus 1 is 5. So this would be function 6, 5, plus 2. So basically, this function is defined by a rewrite of the function with new values, plus 2. Okay? If we know what the value of this function is, then we can solve this problem, but we don't. So now we have to find out what the function of 6, 5 is. All right? How big is your scope? Just stay in here, okay?
Mm-hmm.
So 6, 5. So if we look at that, again, this is a general solution, a recursive solution. 6, 5 says this. X is 6 and y is 5. So we know that x is greater than y, so we rewrite this again. So this is the function of x minus y, that's 6 minus 5, which is 1. So the function of 1, y minus 1, so 5 minus 1 is 4. So the new function is 1, 4. And we also have to remember to add 2 to that. So if I can solve this one, I can solve this one. But I can't solve this one until I can solve this one. So you can see how they sort of chain into each other. Eventually we're going to get to this case where x is not greater than 1. So in this case I'm going to rewrite now function of 1, 4 equals, well, x now is 1 and y is 4. So x is 1, y is 4, so this is false. So therefore, the solution is this. So the function of 1, 4 is equal to 1 plus 4, 1 plus 4, which equals 5. I'm on my third step. Now, since I now know what the function 1, 4 is, I can substitute that into here. You see, 1, 4 is 5. Okay? So if I substitute 5 in for this, 5 plus 2 equals 7. Okay? So now I know what this value is over here. And this value I needed in order to solve this problem. Okay? You notice I worked down this problem, now I'm working my way back up. The way recursion works is you work down until you find a definite solution, and then you find that definite solution and you actually feed it back into what you were working with before. Okay? So now, function of 6, 5, we know what that value is now, it's 7. So if I put 7 in here, 7 plus 2 equals 9. So what we now say is the function of 12, 6, according to these rules, has the value of 9. Is that clear? And that's how recursion works from an ACSL point of view. Now there are problems that have more stages in here. There are problems that have many more interim answers. But you just work your way down until you're able to define the problem clearly. One last thing. Here's a problem. I guess can I put a new one here, a new problem?
Mm-hmm.
Okay, here's a new problem, which is called the function of 6. The function of x is equal to this. First, we always have to define. This is the definition of the function. So therefore, this is the definition of the function. So the function of x is equal to the function of x minus 2 plus 1 if x is greater than 1. However, if x is not greater than 1, if x is equal to 1, if x is equal to 1, the function now is defined as 2. And if x is 0, the function's value is 1. So this is the definition of the recursive function. Again, the recursive function means that there are several solutions depending on the value. This one, it turns out, has many more steps than just 3. This one has 4 or 5 steps or 6 steps, depending on what number you put in. Okay? So if you tried this with a function of 6, let's say, you could work your way down. I'm not going to do it now because I'll let you practice it. Because it's easy to do if you just are careful. So you start out with a function of 6. You know that 6 is greater than 1, so x is greater than 1. This case would apply. I would rewrite this function in terms of this, and then I would rewrite it again and again and again until I would eventually get down to a firm answer, and then the firm answer would then be fed backwards. So the way solutions go in recursion are you go down to find a constant, and then finally you come back up to get the solution to the original problem. And I'm going to stop right now. Thank you.